first one is the website of this software, and here you can see here is overview of this Haploview software, and it can use it to do multiple analysis, and also all the right side menu here you can download. And if you in the future you really want to use this software to analyze your data, you can always go back to this website, and their user manual and tutorial you can find help from here. And okay, click download. And remember, you need to install Java first. And if you use Windows as me, and you can just download this file. And if you use other computer system, you need to download the jar file. Okay, so after you downloaded this file, just follow the instruction, and it is very easy to install this software. And then you just need to open it, and this is what it looks like. And for the input of this software, the many format, and the most widely used one is the linkage format, .pd file. So next, I will show you how to find this file. This file contains the population frequency of different SNPs in different populations. Okay, we can find this file from ensemble. In ensemble, I have shown you how to use this database before. And as Professor Tan just talked about the 1,000 genome data, and this data contains the SNP frequency in different populations. And this project was generated in previous human genome version, the 37 version, and it also contains the data on the current human reference genome. So I just want to show you how to find the data in a previous used human genome version. And when you go to the ensemble database, you can see the current human genome version is 38. And if you want to go back to a previous one, you can see there is a link here. Okay, they look like the same. Okay, so there is a tool named VCF2PD Converter, and the file we need to use as an input for this software is this linkage pedigree file, the .pd. Okay, so we click in, and the name of this drop, and then we need to input the region. You know, there are millions of SNPs in the human genome. You cannot download it, all of them. So usually we will download the SNPs inside a specific gene. For example, we if you still remember, we need to, or maybe we can just click here. Okay. Remember how to find the position of one specific gene. We type the gene name here. For example, IGF-1. Okay, and the first one is the human gene, and here shows some general information about this gene and the location. Then we can find the position of this gene on the 37 human genome version. Then we go back. Okay. And input. Remember, here is the format of the position. There is no CHR in front of the chromosome. And here there are many populations. And for example, we choose the Beijing population, and then we click here. And it may take a few minutes to run this data. Okay. And you can follow the instruction in my PowerPoint. And when you this is what data looks like. And if you click numbers, then it shows the alleles in numbers or show it in character basis. Okay, let's check. Okay, still. It's okay. Let's and there is a example. You can here when you download this file, and there is an example here, and it's very simple. Okay. Okay, I don't know. I tried several times today. It failed, and then I checked the reason. It shows that it can here the remote file not found, so they could not find this remote file. I don't know why, but when the ensemble works fine, and you can try it later. Yeah, maybe not today. Okay, luckily there is an example file here, and in my PowerPoint, when the ensemble is okay, normally then you could see there is a down here, and you click view results, and then you could download the linkage pedigree file, and this is what the file looks like. Okay, and then you just input here, and here is the example data provided by the Haploview software, and here is the column name of the point PD file, but when you need to analyze the data, you need to remove the header. I just want you to know the column names of each column. And here is the pedigree name and number, father ID, mother ID, and here's the SNPs. And also this file contains the position of those SNPs. Okay. And then we just click this one and input this file. And because this contains the family information, this is a family trial data, so we can do association test. Okay, and then we click OK. So here you can see it already calculated all those information for you, like the minor allele frequency, the alleles. And here you can set up some cutoff to select the SNPs that passed your criteria. Okay, and as shown here, all of those SNPs have passed this cutoff, and then we selected all of them, and then when you click here, it can show you the LD plot. And when you put your mouse on each small blocks, and it will, and then click the right button of your mouse, and hold it, and then it will show you the detailed information. And for example, this square shows the correlation, the association between these two SNPs. And you can see the R square is equal to 0.8, and also the frequency of the genotypes. And here, based on the default definition, and it divided those SNPs into 3 blocks. And you can see in each block, the SNPs in each blocks are highly correlated with each other. And then they form a block, and also we could call them haplotypes. And when you click here, it already calculated the frequency of each haplotypes in the population, in the family, or in your data. And this value, if this value close to 0, it means the greater the amount of historical recombination of these 2 blocks. And also you can set some cutoffs to show those blocks. And here, tagger. So tagger. Okay, so there are about 20 SNPs here, and sometimes we could find some taggers for the in these SNPs, and you can just click Run Tagger here, and they found, and this software find 7 SNPs in 7 tests, captured 20 alleles. Here in this table, it shows the R square between the tag they selected and the other SNPs. For example, here, this tag have a high correlation with all of those SNPs, and you can also check it from here. Okay. And also, because the input file is a family trial data, and here is the detailed information of the association between the blocks, and you could also try the permutation test to see whether the association among the blocks are due to random, or they are really associated with each other. And then you could click here and ask it to do, for example, 1,000 permutation, and then you click here, and you can see here is the chi-square value, and here is the permutation p-value, and you can see none of them are less than 0.05. It means that those associations may be by chance, is not true. Yeah. So yeah, that's all for this software. Okay.
Thank you.